Hello everybody, welcome to this lecture on inheritance lookup with a specific focus on self. So the idea of this lecture is that we will look at what is sending a message and the lookup once for all, so after you will know it forever. So basically in this lecture we will look at what is sending a message, what is method lookup, and what is the semantic of self. And by the way, this is also equivalent of this in Java. The semantic is exactly the same in both. They are just different syntax, but this is the same in Java, C#, Pharo. So if you remember in the previous lecture, we mentioned that inheritance has two aspects. One that is the inheritance of state, which is basically static because it is done at compile time. So this is at the moment where you define a class, the compiler knows that the state of an instance will be represented by the state of the class and the state of its superclass. And inheritance has also a dynamic aspect that is the inheritance of the behavior. So this means that when I send a message, which method should I execute? And this is on this part that we will focus now. So if you see, the key aspect, this is what is sending a message. Sending a message, this is also in Java, by the way, this is also called, I call a method or I invoke a method. Personally, I prefer the term sending a message because it implies that there is a lookup. So if we look at it, sending a message, this is a two-step process. So first, we have the lookup of the method, and second, we execute the method that we found on the receiver. And you will see that this is really important. Normally, we have some little video later in the MOOC that really said, do you really understand lookup? And basically, this is based on these two steps, because often you mix things, you get something that is working more or less, it works more or less, up until we can know exactly if you don't understand. So if I look at this example on the right, when I send the message area to a colored rectangle, I will first do the lookup. So the lookup will look for the methods. Oh, is there a method named area? Yes, there is one. I return the method, which is this one, and I apply this method on the receiver. So you see, one step, two steps. Now let's look at the method lookup. So the method lookup, this is the first step that we saw. So what's happened is that the method lookup starts in the class of the receiver. So when I send the message area, the first thing that I do here, one step, I go to the class level. So when I go to the class level, then I will check inside the class. Oh, is there the method that I'm looking for? Yes, no. If this is not the case, I will go up, and when I find it, I just return it. What is important to see is that this step, the first step, will make that in system like Pharo, where class are objects, the same method lookup works for both instance and classes. If you are fuzzy on that, I strongly encourage you to have a look at the video of the first MOOC, because that really explains well the meta class and the fact that there is only one single method lookup. So if we look at it, so this is basic things here. If I send the message color to my colored rectangle, I jump here. I see, oh, this is color, I return it. If I send the message area here, I jump to the class. This is not found here, I return it. Nothing special here. This is super basic. So, just an intermezzo. Most of the time, the result of a lookup is cached, and it only happens once for a given call. In some languages like C++, you have dispatch tables. What is very important, the point that you should take is that conceptually there is a method lookup at execution, and that virtual machines are smart enough to not always look for the method. So now let's look at what is self or this for real. So what I suggest is that take 5 minutes, write the definition on a little piece of paper, put pause on the video. With your definition should have 2 points. What self represents and how the method lookup happens when a message is sent to self. Why do I have these 2 points? Because in the lecture on super, you will see that there is a difference, And the difference is only in one of the two points. So this is important that for self or this, you have 2 points like that, you will be able to compare. So now, before my definition or the correct definition, I will propose you some little exercises. So first, a convention that we use in this MOOC, so this means that when we write A, this is an instance of A. So this means that if we are in Pharo, we will write A equals A new. This is the result. If you are in Java, you will write A equals new A. So we have this setup where we have A is an instance of the class A, B is an instance of the class B. Now, what is the result if I send a message foo to A? So I send a message to A. Now I know, I look in the class, there is foo, okay, this return 10, so I get 10. Now I have my instance B, instance of the class B, I send the message foo, I look for foo, okay, I find it, okay, I return 50. Let's look at it. Yes, we were right, that's so cool. So here I said self always represent the receiver. And this is what we will see in the next exercise. So let's take a more challenging exercise. So now we will look for this expression. So we send the message bar to A. So the method bar, we look in the class, we find bar, it is defined here, and then we will apply bar to this. If you remember the message passing, I said we look for something, we look for the method, we find the method, we apply it on the receiver. And then self, in that case, represent the receiver. This is what is written in the title. So this means that I will send a new message, foo, to the same object. I will go up again, I find foo, okay, this is 10, we got 10. So what you could say is that basically, we could only find 10 because there is only 10. From the perspective of A, there is only 10. Now, what is interesting, this is this example, this expression, B bar. So what I suggest is that just take 2 minutes and just ask yourself, okay, what is the result? Is it 10 or 50? And what you should know is that you have a good chance to get it wrong. This is what we really want to make clear. So I send the message bar. I look for bar in the class of B. There is no bar. So we go up. We find bar. Oh, there is bar. We find this method, which is the same as before. So now we do the same. We apply the methods on B. And self here, this is what? This is the receiver. So here, this is a B. And then the message foo is sent to B, to the instance. So we look for B, we find B here, and we return it here. And here we get 50. So what you see is that even if the method was defined in the superclass, the method of the subclass was called in place of the method of the superclass. So if I erase a bit to make the things clearer, it means that the method foo that is executed here depends on the receiver. So if I get an instance of B, this is this method that is executed. If I get an instance of A, it is this method that is executed, even if the method was defined in the superclass. And this is really the key aspect of object orientation. You see the method lookup and the late binding that is happening here. What I show you here, this is the same in Java if you only use public method in Java. If you use private methods, then you get different results because the private keyword has a different semantic than public methods. So here on this slide, you have already the explanation. You can go over it. Let's go fast. So This means that B is instance of the class B. There is no method bar in B, so we look up bar in A. We found the method bar in A. The method bar is executed, and I would add on a B. Self refer to a B, so this means that we will resend foo to self, so to the B. So we look up for B in the class B, and then we return this method that is executed. My definition and the good definition, the correct definition of this or super says that self represents the receiver of the message. And then the second sentence, this is the method lookup start in the class of the receiver. What is important is that in this definition, sometimes people say this is the current instance. The problem is that for me, current instance, I don't know current of what. And I always think, oh, if I have concurrent processes, is it different or not? So here, this is very clear. This is based on the message. This is for a message. Self represents the receiver. Just a little variation. This is not because we introduce an empty class in the middle that it changes anything. So this means that here, as you should guess right, I will get 10, 10, and 50. Why? Because the lookup goes like that. So if I send the message bar, if I send the message bar to a C, I will go up, find the method bar, apply it to C, redo a lookup for foo, and this is exactly the same mechanism that I explained before. So you don't have to have the method one by one in the class and the superclass. So you see. So what you should know from this lecture. So self always represents the receiver. Sending a message is a two-step process. We look for the method and we execute the method on the receiver. The lookup method, in fact, maps a message to a method, and it starts in the class of the receiver. What you will see is that this is a bit different when you use the super keyword, and this is what is explained in the super lecture.